Well, thanks, Sean. Hello, everybody. Good afternoon, good evening, good morning. My name is Brian Nice. I am a principal program manager within our team's customer engineering team. And I am going to take you through very rapidly a discussion around network. So without further ado, let's dig in. So quick little intro we'll do on network pieces. We'll talk about the overall network architecture with our global network. We'll cover the O365 connectivity principles that we have, and we'll talk about everybody's favorite, which are media flows. I am going to caveat this by saying there is a ton of content that we have on networking, and there's absolutely no way that I can cover this in, well, now less than an hour. It's just not going to happen. But if you take a look at this aka.ms link that I have on the slide here, you can gain access to any of the decks that I'm using here, any of the audio samples that you're going to hear shortly, as well as deeper dives on all of these various topics at that location. All right, so that's a handy URL to have, especially as we go throughout this presentation, because I'm going to show you some audio examples of what we've been doing in the media stack. And if you want to be able to listen to them, maybe more clearly on your own or take them away, you can get them in the deck that's located on Teams Academy. So the key message that we wanted to be able to lay out there from a meetings perspective, from a media perspective, is that it's not rocket science, right? Meetings should just work, and they do. With Teams, meetings just work. All we need is a link. Click the link, boom, we're done. Not rocket science. Those of us that have come from the legacy days, shall we say, right, that have used those wonderful products like OCS and Live Meeting and Link and Skype and all those fun things, we always had a bit of consternation when it came to meetings, right? And as you might expect, we would see some common issues in the Skype for Business world, like, being able to properly join meetings in a consistent fashion. So we realized that we needed to make some architectural changes when it came to Teams. And some of those changes were, of course, around to directly impact some of the common issues that we saw in Skype for Business. Now, I'm not going to drain this entire slide, but really there were key investments that we did in the product itself to help address many of the challenges that we saw in the Skype for Business world. So the ability to successfully join meetings in a consistent fashion, being able to join with dial back mechanisms, staying connected to meetings, right? The mid-call drop scenarios, tackling quality, which I'm going to talk about a little bit later, being able to simplify the whitelisting that we do for IPs, ports, URLs, things of that nature, right? Those were always very common challenges, and putting that onus on the end customer really kind of hampered our ability to get a good quality experience in the Skype for Business world. Not to mention, you had to download this lightweight, quote unquote, client that was, probably close to 100 meg anyway, in the Skype for Business world. So we wanted to be able to improve that by getting, web clients and being able to experience a meeting without downloading anything if we so desire, right? We also wanted to make sure that we made the meetings experience simple, right? And my colleagues are going to dive deeper into, more of the meetings experience later today and tomorrow. But most of you that have, lived and worked in the Teams space already recognize how much simpler we've tried to make the experience in Teams compared to some of our predecessors, right? So giving us that one-click join experience and actually making it work, right? Picking the right AV devices for them, giving better user-facing diagnostics as needed. The BYOM concept, bring your own meeting concept, right, where we can do proximity joins, things of that nature, which we'll cover more in the rooms, session. So lots of ways that we've tried to approach in-box, in product, to make sure that meetings can be simpler, right? But for me, proof is in the pudding, right? Seeing is believing. Let's just see some of the changes, and let's actually, hear some of the changes that we've done. Now, I'm going to show a couple of slides here that talk about some of the media stack improvements that we've done. The link that I've placed into this slide, this aka.ms link, and I'll stay here for a moment, is the deck that contains these particular slides that have these audio samples in them. right? So I will play them through the live event here, so you guys get a chance to listen to them. But if you want to be able to listen to them on your own, there are also some additional slides that I'm not going to show here for obvious reasons. We joked about it a little in the pre-call for this. I'm not going to show the howling, the improvements that we've done, because it would probably drive you batty if we turned on the howling mechanism right now. So bear with me one sec. I'm going to turn on my system audio. And first thing we're going to talk about, crystal clear audio in ultra low bandwidth. Some of you may have heard this referred to as the SATN codec. This is a new codec that we've been working on that provides the ability for us to have crystal clear audio utilizing ultra low bandwidth in scenarios as low as 7 kilobits per second. So what you're going to hear in this little demo is you're going to kind of hear the before and the after aspects of this particular codec. So let's give this a try.
The coffee stand is too high for the couch. The coffee stand is too high for the couch.
The set of china hit the floor with a crash. The set of china hit the floor with a crash.
The ship was torn apart on the sharp reef. The ship was torn apart on the sharp reef.
Pretty cool, right? That first clip that you're hearing was our normal, standard audio codec that we would utilize, and the second was using our SATN codec. So still being able to get that crystal clear audio, but utilizing ultra low bandwidth. Pretty cool stuff. In addition to working with ultra low bandwidth, probably my favorite demo is this one, right? The smooth audio over spotty networks, right? This 30% burst loss. So like we saw on the last slide, we're going to do a snippet for you without this this media processing, and then with. So you're going to hear, what this looks like when we're dealing with smooth audio over a spotty network that has up to 30% burst loss. A scenario for that might be you're on mobile, right? You're on a mobile client, you're on data, you're switching towers, you've got a bad signal, maybe you're latched onto the tower that's furthest away from you and you keep going further, right? So let's take a listen to this one.
Statistical mechanics is the place of entropy and law dynamics. Entropy always increases. Among other things, the second law allows to dismiss claims perpetual motion machines. Statistical mechanics is the birthplace of entropy and the second law of thermodynamics. Entropy always increases. Among other things, the second law allows one to dismiss any claims to perpetual motion machines.
That to me just kind of blows my mind, right? You listen to that first one and you could barely make out what we were trying to say across that 30% burst loss. And yet being able to conceal that with our codecs, to be able to hear it as clearly as we did with up to 30% burst loss is awesome, right? And that's just naturally built in to the solution itself, right? Nothing you need to do to make that work. The last demo that I'll do here is minimizing background noise in open space. Obviously, based on kind of the way things are right now, we don't have a lot of gatherings like this. That's not proper social distancing. But we do want to make sure that we have the ability to minimize this background noise when you are in an open space environment like a cafe or a coffee shop or something of that nature. So again, like we saw before, we'll listen to the before and we'll listen to the after. Pretty cool, right? Pretty nifty stuff. All right, I'm going to turn off my audio here and we're going to jump in past the demos. And we're going to talk about, now that we've seen what we've done in Box and we've seen just how easy it is to get teams running from a meetings perspective, let's talk about how we can optimize our meeting and calling experience. So again, I think about this when I work with my customers and partners. We don't really need to look at this from the perspective of, oh, you want to turn on meetings? Yeah, ooh, that's a difficult workload. It's going to take us 6 months, 9 months, 12 months to figure. No, the meetings workload in Teams just works. Let's turn it on, right? We don't, in a lot of cases, have to go and deal with hours and hours and hours and hours of really deep technical discussions just to get the product to work. Now, there are absolutely ways that we can optimize the meeting and calling experience, and that's where we're going to dive into in this section, right? To understand how we optimize, first we need to better understand how the traffic flows actually work. So this is the way that a lot of customers and partners kind of envision or explain the way that we connect to Office 365. On the left-hand side, this is my colleague Martin, right? On the left-hand side, folks believe, well, we've got this corporate network. I own the corporate network. I have full control. I basically can manage everything. And then you've got this kind of internet thingy here that gets you, and that's a technical term, right? This internet thingy here that gets you over into the service, and poof, we're there. That's how we connect to Office 365. Yeah, the reality of that is no, that's not how we connect to Office 365, right? We're missing a crucial piece of the puzzle in that. Yes, there is a corporate network, right? Yes, there is the internet, right? But there's also the Microsoft network, right? This is kind of what we call the ingress into the Microsoft environment, into the Microsoft Azure network. You'll often hear this referred to as kind of the Azure front door, right? And I'll talk more about that in a little bit in the specifics of Teams when we talk about things like transport relays or media processors, right? But this is important because you have to understand these three chunks of paths, because each one of these are handled differently, right? The corporate network is, of course, under control of the organization. So they have direct access to the routers and switches. They can turn all the various nerd knobs that they need to turn to further optimize that corporate network. But it comes at a cost, right? So they have to understand how to properly manage that. How do they deal with the WAN connections and so on and so forth. On the flip side of that, you have the Microsoft network. That's on us, right? That is our Azure network. We need to manage that. We are responsible for ensuring that that Azure network works, right? And you'll see on the next slide kind of that, and I'm sure many of you have seen it before, the visual of just how broad our network is from an Azure networking perspective, right? This is managed by us. The latency in this, I mean, this is all dark fiber. So it's really only imposed by the distance and speed of light. Dang physics, right? That's where we're restricted and gated on the Microsoft network. And then you have this middle piece, which is the internet, right? That's kind of the piece of the puzzle that we often focus most on, especially nowadays when we have tons of people doing the work from home thing, right? But the idea of this internet segment, there's very limited control here, right? About all you can do is choose the right ISP, right? And I'll talk about what a right ISP is in a second. And maybe get some more bandwidth. Now, comparing that to corporate network, it's usually you can get higher bandwidth on an internet circuit than you can on a WAN circuit at a lower cost point. So a lot of times from an optimization perspective, this is quite attractive, right? Rather than backhauling things through corporate, through these expensive WAN links, what if we go to these remote offices and break them out onto local internet circuits? That's the start of the discussion for how we optimize this connectivity to Office 365. Like I say, you've probably seen this before. Here it is again. Just gives you a visual representation, and this is not even the most current, version, but it at least shows you the depth and scale for the Microsoft Global Network. Right? This is the backbone on which we run Office 365. And that doesn't just include Teams, right? That's all of Office 365 that we run through the Microsoft Global Network. This network, of course, has a global footprint as being one of the largest networks in the world, right? We have tons and tons of dark fiber that's out there. We have many peering relationships. Now, this is an important component, and if you don't come out of the networking world, you may not understand the concept of peering, but look at it this way. The idea of peering basically means that the ISP, right, where we're getting our internet connection from, that ISP has a routing relationship with us, right? They're peered with us, meaning that they understand from a routing perspective the shortest path to get from their ISP network into our network, into our Azure network, right? We often do this through BGP peering, things of that nature, but it's basically an optimized routing topology, right? Think of it as, you're at your house and you want to go to the store, right? There's probably 100 different ways to get there, but there's one way that's the fastest way, right? That if you have that knowledge, you've effectively got a peering relationship with that store because you know how to get there the fastest. That's what we do with over, well, this number is dated, but well over 2,700 ISPs, So this is one of the first pieces that I look at when I work with customers, and we start looking at this idea of having the localized internet breakout. Have you selected an ISP that has peered with Microsoft? Now that's ideal, right? Of course, you're always going to run into the corner cases where maybe you're in a rural area here in the US and you only have one ISP, right, that you can pick from, and they happen to be doubling as, you know, a bait and tackle shop. So hey, you kind of get what you get, but this is something you should be thinking through from a corporate perspective to make sure that you understand that there are choices that are out there. You can even make requests of the ISPs. Hey, can you peer with Microsoft? Our AS number is out there, and organizations can peer, or ISPs can peer directly with Microsoft as so desired. Now, in addition to the peering, we've also deployed architectural components from a Teams perspective that aid in the processing and experience of meetings. These are media processors and transport relays. I'll talk about them in the second half of this presentation. This network has been optimized for media purposes, right? Now, again, I mentioned that this network is for all of Office 365 all up, but it's optimized for media. You know, we're running fiber connections to make sure that we can reduce latency as much as, you know, physically possible, right? We have these edge sites that are placed close to users to bring the cloud as close to them as possible. That's bringing that Azure front door as close to the user as we can. Those are our transport relays that we'll get to in a bit. We continue to improve the ISP peering, you know, mechanism. Of course, audio traffic is prioritized throughout our network. Meeting hosting, we try to bring the meetings as close to the participants as possible as well. Again, more to come on that a little bit later. And most importantly, with this restructure of this network, we've tried to consolidate our IP ranges down to a very small set of subnets. What originally was 2 subnets, it's now 3 subnets. Talk about that in a sec. But we've consolidated these IP ranges down for calling in media. That way we can make it more simplified and an easier experience for the security folks, for the firewall admins to basically know, hey, it's only these 3 subnets and these 4 ports that we need to worry about from a media perspective to give us the best experience possible, right? Just a little fun trivia, our fiber optic network could stretch up to the moon and back 3 times over. That's just a lot of fiber, right? It's good stuff. But the key of all of this is the fact that latency, in fact, low latency, that's the currency that we want in the software as a service world, right? This is the mental shift that customers and partners need to make, right? The way that you architect a network for SaaS is different from the way that you have traditionally architected a corporate network. Right, corporate networks were traditionally done with, you know, hub and spoke models. We had a lot of centralized internet where we'd bring everything home run back to the central office. We do all of our content inspection there. Like we do all of these things that kind of made sense in the on-premises, you know, type world. But now that we're dealing with SaaS, right, software as a service, the model's changed, right? And we want to ensure that our latency is as low as it can possibly be. Specifically, the end user impacted latency pieces. And where is that really going to be, you know, seen? It's between the end user and this Azure front door, right? The AFD, or the Azure front door, that is the entry point into our managed network, into the Microsoft managed network. Now, the user comes from either a corporate network, or again, this could be their home network, right, as well as we're seeing in today's times. There's an internet circuit, and then we get into our Azure front door. We want to try to reduce latency as much as possible here, right? Because everything on this side, getting into the tenant, getting into the data, getting into all the other components, that's on our backbone, and that's on us to make sure that we have that managed properly from a quality perspective. So when we look at these from a Teams perspective, we have the ability to assist folks getting into our network quicker by putting components out there like transport relays, right, and media processors. The main difference between the two, transport relays, are just what they sound like, right? A relay relays traffic, right? So if I can't reach another endpoint, I could go to the relay and the relay would send it on my behalf, versus a media processor actually does some processing, right? Those are the resources that we actually use to host meetings, among other things, right? Again, more stuff to come as we talk about TR and NMPs a little later in this session. This is one of the other key strategies that we have to make sure that we fully grok when we're talking about networking for Office 365 all up. And I think that's an important statement because a lot of times, especially for those of us that have lived and breathed Microsoft UC for the last umpteen years, we can't just look at this only from the Teams perspective, right? Because as all of you know, Teams isn't an isolated product, right? Teams, to me, Teams is the center of gravity for Office 365, right? You look at Teams, and yes, we're talking about meetings and we're talking about calling, but Teams really has that interconnect into all of these various components of Office 365, right? So when we talk about optimizing the network, we have to optimize it for Office 365 all up to get the best all around Teams experience, right? The way that we want to do that is to make sure that organizations understand how to improve their routing topologies for software as a service. Now, this is where conversations either go really well or really horrible, depending on how you present this to your customers and, of course, who your audience is, right? If you look at the slide here, the visual representation, we have our main office here, right? We have a branch office here. Of course, the main office has an internet connection, right, through our ISP to get to the Microsoft network. What we're showing on this slide is the branch offices, rather than going up through the head office and out their internet circuit, ideally, you should improve this routing mechanism by having the branch office have its own internet connection to allow traffic to egress directly from the branch office. Now, if you just leave it at that, and you say to a customer, well, just put an internet segment, you know, an internet link in your branch office and let all the web traffic go out there, the security guys will be on you in a heartbeat because they're going to be like, no, we've got to bring that through the head office because I got to do content inspection. I've got to do URL filtering. I got it, right? All the things that security loves to do, and rightfully so. The way that we need to address this with customers and with, you know, security folks is I'm not asking you to break out all of your internet traffic from this branch office. I'm asking you to optimize your routing of my SaaS traffic, my Office 365 traffic, right? That's a different conversation because, hey, you want to stop people from going to YouTube? Hey, you know what? The YouTube traffic, that still goes this way. That still goes up to the head office, and you can do whatever content filtering you want. I'm just simply asking that at this branch office, you identify the trusted traffic, the Office 365 traffic, and you route that accordingly, right? I'll get more into that on the next slide. This third bullet is very appropriate for this day and age. Split tunnel, split VPN for remote users, right? Getting organizations to understand that same concept that I just talked about for the branch office should be extended to the home office as well. Yes, I know that you have corporate assets that are living inside of your corporate data centers. Allow them to tunnel VPN to get to those resources, no problem. But when it comes to media and optimized traffic for Office 365, don't bring that through your VPN. Send that direct to the service. Because if we try to bring it through the VPN, one, we're probably going to overload those concentrators because I guarantee they weren't sized for the situation that we're in today with COVID, right? But number two, even if it wasn't a capacity issue from that perspective, it's a latency issue, right? You've just gone 10 directions out of your way to get to the store rather than taking that straight path to get where you need to go, right? You can see in the bottom right, aka.ms/PNC, that's our principles of network connectivity. That's where this all comes from. You really should all understand how that construct works. So that's great, Brian. It's nice of you to sit in your ivory tower, right, and tell people this is how it should be. But I'm in the trenches talking to the security guys, and they're like, no, I'm not going to split out my web traffic because it's not secure. Well, we need to be able to sit down with the network and security folks and explain to them the concept of IP categorization. Again, when you talk to these network folks and you talk to the security folks, it's not about breaking out all of your internet traffic. It's breaking out the trusted, optimized components of Office 365, right? Now, back in the day, we basically gave you this big old web page that had thousands of IPs and URLs on it. And we said, here, open all these up. That usually gave, folks the little bit of the jitters. They're like, yeah, I'm not gonna open all that stuff, right? So we said, okay, well, we'll consolidate it down. We'll make it a little bit better. Instead of thousands, we'll make it hundreds. And they still kind of flinched a bit, right, when we consolidated these things down. So what we then did was built out a priority-driven taxonomy for our endpoints. 3 basic categories: optimize, allow, and default. The reason that these categories exist is not so that an organization can say, oh, well, I only have to do optimize. Well, no, I mean, you have to open allow and you have to open default, right? I mean, these are not negotiable, right? These are the ports and URLs and so forth that we need to use. The reason these categories are here is to help organizations understand how they can treat these types of traffic differently, right? So optimize is a couple of FQDNs and 20-ish subnets for Exchange, couple FQDNs, 15 subnets for SharePoint. Technically, it's 3 IP subnets now. I should have updated that, not 2, but it's 3 IP subnets for Skype for Business and Teams, all of which fall into this optimized category. Now, what's important about the optimized category is this is the traffic that is most susceptible to latency issues. So by building out these categories, I can go to the network folks and say, hey, that branch office, I'm not asking you to break out all traffic for the internet. In fact, I'm not even asking you to break out all Office 365 traffic for that. I'm asking you to break out this set of traffic, the optimized traffic. If you can take that set of IPs and URLs and subnets and just allow that small segment of traffic to directly egress rather than go back through corporate, you are going to have the best possible experience with Office 365. And hey, if you look at this breakdown of optimize, right? Bypass of BNI, break and inspect for SSL, proxy bypass is recommended, first priority, right? High volume. If you tried to apply those parameters to all traffic, the security guys will laugh you out of the room. But if you apply those just to this small subset of traffic, that's a much more palatable discussion to have. And at the end of the day, again, we kind of go back to the network and security folks and go, well, is Office 365 a trusted service or not? It's not like this is, Bob's bait and tackle that just spun up a web server somewhere, right? This is a defined service that has multiple compliance mechanisms built into it. Do you trust the service or not? Heck, you've already given us your data when you synchronized Azure AD. Isn't that like the keys to the kingdom already? Don't you already trust us? In that instance, how about you take these optimized paths and do that for me? The stuff that's in allow, the stuff that's in default, if you want to route that back through corporate, you could do that, right? And in some cases, you could even do your default treatment, right? Put it down in the default, priority queue for QoS if you so desire, right? All of this is available through an API as well, by the way. And there's a number of folks that, firewall vendors and so forth that actually subscribe to this and give you a little button in their UI that say optimize Office 365 traffic, and bink, and it'll pull down all of these for you so they don't even have to go in and manually enter this stuff, right? The key point of this entire slide is optimize. Got to focus on that optimize, right? From a routing perspective, from an improvements perspective. Don't over-rotate on this and think, well, Brian said I only have to open the things that are in optimize. I didn't say that. I said the things that you want to optimize from a pathing perspective are in this optimize category. You still need to open the URLs and ports that are listed in allow and the ones that are listed in default. You still need those. You just maybe don't have to take them out the local internet egress. Okay. Another AKAMS link there from an old session that we did back at Ignite that covers this concept in greater detail if you want to get more info on it. Here's our little chart that talks about how we optimize the connectivity specifically to Teams. This is what used to be 2 is now 3 subnets. For those of you that are keeping score at home, we recently published this update of 52.120.0.0/14. This actually does not take effect until the end of May, so you still have some time. But the reason that this subnet was added was for additional capacity. right? This subnet is for additional media processors and transport relays, well, mostly media processors, in that particular subnet that we're adding as a precaution for future expansion, right? And the reason we added it now is because obviously we don't want this optimized category to change very often. And truthfully, it hasn't changed until like just recently as a result of the COVID experiences that we've had. So we wanted to get this out there, make sure that folks are aware of it. We haven't started using IPs in that subnet yet, but you need to go and make sure that your customers, if they're not using the API, that they're aware that there's a new subnet that they're going to need to add for. Okay. So from an optimization standpoint, right, that's your traditional environment where everything goes through the central office. We don't have that breakout that we would need at the local site. This is our recommended path that we go through, that we have local internet breakouts for the specific Office 365 traffic classifications that we've talked about. Please don't leave out that last part because that's really important. Again, if you go to network guys, you go to security guys, and all you say is you need a local internet breakout for internet traffic, they're going to turf you because they still need, rightfully so, to be able to do the things that they need to do from a content inspection perspective and so forth, right? So please keep that piece in mind as you're having these discussions with your customers, because that's what resonates for me as I talk to customers and I talk to security folks and I talk to network folks is I'm simply asking for an optimized path for specific targets in a trusted environment, which is Office 365. Okay, rolling right on through here. Let's get into TRs and media processors. Yeah, transport relays and media processors are always fun. Let's look at the principles of a transport relay first. We'll start there. In the world of Teams, UDP is king, right? When in doubt, when we prefer, everything we want to make sure goes UDP, right? A direct connection is even better, right? So here on this slide, my colleague Martin, my colleague Zoran, when they talk to each other in a peer-to-peer mechanism, ideally, I want that to go direct, right? From Martin to Zoran, Zoran to Martin via UDP. That's going to help me get there as best as I can. But that might work if they're sitting in the same room, but chances of that happening right now are pretty slim since, well, you know, kind of an ocean separates the two of them right now. So that's where we get into the need for transport relays. Transport relays are used as a fallback mechanism to establish connections to a second endpoint, right? A second endpoint could be another Teams user. A second endpoint could be a Teams component like a media processor, right? So the idea of a transport relay is to help relay traffic in a situation where the user's Teams client doesn't have a direct connection to the far end endpoint that they're trying to connect to. Now, the client to client as ideal would be UDP. But if for whatever reason, maybe the firewall folks just are like, nah, sorry, dude, we don't do UDP around here, right? We only do TCP. So of course, if I try to make that UDP connection, it fails even if I had direct connectivity to them, if I have to pass through a firewall that blocks it, right? Well, the client to transport relay could use UDP, it could use TCP, it could even use HTTP if it needs to, right? So we have lots of fallback mechanisms in play to allow the Teams media session to succeed. Now, this particular user, while he may be blocked with UDP, maybe he's using TCP on this side, the other side of the transport relay is going to be UDP if it's at all possible, right? We only have UDP candidates that we offer on this side. If UDP is blocked for Zoran here, well, then Zoran will get his own transport relay that he can talk to, and then the two TRs will talk to themselves. So the idea of this transport relay is to be able to have that fallback mechanism as necessary. Now, we reach these transport relays by connecting to an Anycast IP address, right? That way, it allows us to do some optimization from a global routing perspective, right? So that you can hit a transport relay cluster that is closest to you, right? The TRs are basically something that we have built in the service. And utilizing this Anycast IP routing mechanism, we ensure that we get users as close, quote unquote, as possible to the instance. Now we use quotes there for a couple of reasons, because we're only going to get you as close as where we think you are, right? So again, I'm down here in sunny Southern California, right? My transport relays and my off Azure front doors are actually in Northern California. They're up in San Jose. But if for some reason, I was connected over VPN and the VPN took me into a head office that was over on the East Coast in, say, New York, and I dumped out to an internet circuit on New York, well, when I go to hit that Anycast IP address, it's going to think I'm in New York, and it's going to route me most likely to a cluster of TRs that are on the East Coast. But in reality, I'm on the West Coast. You see how improper routing leads to bad decisions, right? This is why it's important to follow the connectivity guidance that we give, because we're doing optimizations and making decisions based on the ingress into the Azure front door. Where do we see you coming from? And if where you're entering is not actually where you are, that could cause some problems down the road, right? So it looks like this, right? And this should look pretty familiar for any of you that have looked at, the old Edge, server stuff that we used to do, the AV Edge stuff back in the Skype and Link days, right? We connected this Anycast IP, which redirects us back with a 401 unauthorized. That's expected because we're not authing to this. We're basically hitting the Anycast IP, and then it's going to use its logic to say, oh yeah, you need to go to this cluster over here based on the location that I see you coming in from. You'll get routed to this next transport relay, and away you go. You'll start the stun process. You'll be able to auth just like we would have expected over UDP 3478, and then away we go. Okay. Now 3478, important port, UDP 3478, because that is always what we use for the initial comms with the TR, with the transport relay. Now, the TR itself also allocates workload-specific UDP ports, right? So you can see the transport relay, right, on its other facing side here is allocating port 3479 for audio, 3480 for video, and 3481 for sharing, right? That's for the far side endpoints to connect to, right? And that, again, could be another client. It could be an endpoint like a media processor. It could be whatever else we're trying to connect to on the other end. But here's the trick. From a client perspective, the ports that the clients use to connect up to the TR is dependent on this little toggle switch that we have in Teams Admin Center. Insert quality of service markers for real-time media traffic. If this is off, which it is by default when you provision a brand new tenant, we don't use individual ports for the various workloads. It all stays on UDP 3478, right? It's basically a mechanism that we use to bundle. Port bundling is what it's called, AV bundling, where we bundle together audio video sharing all on these specific ports, right? If you were to toggle that switch and then go make a cup of coffee and hurry up and wait for the replication and all that to happen, you'll get separate ports that start to be used for those respective media streams, right? So 3479 for audio, 80 for video, 81 for sharing. So if you're doing some Wireshark tracing or Netmon capturing or what have you, and you're just like, dude, I don't see these ports that Brian's talking about, first thing to do is check to see if this particular enable QoS flag is what it is in PowerShell, but make sure that this toggle is actually turned on. What if TCP is blocked on one side? Right here, I should say UDP blocked on one side. Typos, gotta love it. If UDP is blocked on one side, what do we do, right? This first connection, like we said, is a stun connection over UDP 3478. But what if the firewall folks are just like adamant? No, I've seen some articles somewhere on some site that said UDP bad, so I'm not going to allow it. Well, of course, you're going to have that discussion about why UDP isn't bad. But in the meantime, what does the product do? Well, we have fallback mechanisms in play, right? Like we talked about before, the client to TR prefers UDP, but it can fall back to TCP or HTTP as necessary. Now, again, remember, that's for this guy to talk to the TR. The TR is still going to allocate individual ports on this side only using UDP. So we're expecting the endpoint on the other side to be able to make a UDP connection to these ports. And if this is blocked here as well, then my buddy Zoran here will get his own transport relay that he can talk to over TCP, and the two TRs will talk to each other over UDP over our Azure backbone. Right? So quality of service always comes into play. And the amount of time I have here to talk about QoS is not going to do it justice. But it is important to realize that we can do quality of service in Teams the same way we did quality of service in Skype for Business. More specifically, we use the same ports that we used in the Skype for Business world with Teams. So if you've already configured your corporate network for QoS, you're ready to roll with Teams. Maybe you need to make some minor updates if you're doing group policies, right, that point to an executable. Maybe update that to point to Teams rather than pointing to, the Skype executable. But the infrastructure components, if you're doing port-based, QoS, you shouldn't really have to worry too much about making, huge changes on this side. They're more minor changes, right? Updating ACLs for the return traffic because we have new IP subnets that we're using, right? Maybe updating group policy, things of that nature, right? Obviously, local breakouts will help to reduce the perceived importance of QoS. It doesn't eliminate it, right? Because remember, if you have two users on the same corporate network, they're going to go across the WAN to try and talk to each other by default, right? So it's still important, but it reduces its importance, especially when it comes to the meeting scenario, because now meeting joins are all going out this local internet circuit, which ideally is paired with our Azure network, with our AS number, right? Which I think I don't even remember if we had put it on a slide before, but our autonomous system number is 8075. So you can always go out to aka.ms/8075, and that'll give you all of our peering info. But your traffic now breaks out that local internet circuit, goes through a short distance path to get onto the Azure network, and boom, you're in. Makes QoS a little bit less of a critical issue at that stage. And that's important to understand because that directly translates to the world of work from home, right? I'm not going to go, I have Cox Communications for my internet provider. I'm not going to be going to Cox Communications and setting up QoS. Just not going to happen, right? I can handle that here on my home network if I so desire. But once it hits the local internet, not much I'm going to be able to do there, right? So I want to make sure that, again, from a corporate perspective, I've got that local internet breakout, and ideally this carrier is paired with Microsoft so that we can get on the Microsoft network as quickly as possible. A few notes about this particular slide. This toggle, like we said, turns on the ability for the ports, custom port ranges to be used, as well as the custom ports that we talked about per workload, right? So toggling this, you get UDP 3479, 8081, but you also get whatever ports that you have listed down here that get respected, right, by iOS, Android, Mac. Windows, again, with Windows, you have to use a GPO to actually get it to tag the traffic, right? When we talk about DSCP markings, right, differentiated services code point is DSCP. When we talk about the actual DSCP markings themselves, right, turning this switch on, Android will do it. Mac OS and iOS, not so much, right? And part of that has to do with the API set that Apple uses. We do the best that we can do with the API that's been given to tell the systems, please mark this traffic as EF, and what have you. Android does it beautifully, which is great because our phones are also Android. iOS and Mac OS, not so great, right? So your experience may vary when it comes to that. We are working diligently with Apple to try to, work through these issues, but right now we're doing what we can with the API that they've given us, right? When you're building out policies, don't use the destination ports on a transport relay, right? Because you may run into situations where you don't need a TR, right? You might join a meeting and have direct connectivity to a media processor. There's no need to put a relay in front of it and add that extra hop when you have a direct connection straight to the media processor. So don't restrict this down just to TRs, right? Because I have a lot of folks ask me, well, tell me where all the transport relays are located. Why? You shouldn't be signaling them out anyway. We insert them when we need, follow our base guidance, and you'll be good to go. And oh goodness, I haven't even gotten to media flows yet, and I only have like 7 minutes. Fantastic. So the last piece are bandwidth controls, right? We do have bandwidth controls available. You can set things like the media bitrate that we see here. The media stack will, of course, attempt to optimize based on end user conditions. You don't have a direct control over a codec per se, right? You can't say, I want everybody to use Satin. Yeah, no, the media stack will take care of that for you, right? But you can influence, right, some of the behaviors that the media stack will do based on setting things like the media bitrate, right? And the media bitrate itself controls the average cumulative bandwidth consumption of all modalities. Right? This is not set on a per modality basis. This is constructed based on that average cumulative bandwidth consumption for all modalities. So, if I hit that default base media bitrate, I should see roughly the average cumulative bandwidth consumption that you see here. All right. Last but not least, I'm going to blow through very quickly the concept of media flows. Again, I don't have time in this session to go into the gory detail of media flows, but you're in luck. We have an entire session out on Teams Academy that covers media flows soup to nuts, right? Covers the entire constructs of media flows. I'm going to touch on a few basic ones here. The fact that we have two different types of flows or types of calls that we deal with, direct calls and meetings, right? A direct call is more of a peer-to-peer or point-to-point call. Typically, that's a two-user ad hoc type mechanism, right? We kind of blur the lines here because, yes, I know you could have a meeting that you schedule with two people, right? What we mean by direct calls here would be, if I fired up my Teams client and I make a call directly to Sean, right? That's a direct call, right? I'm not setting up a meeting and then only Sean and I join it. It's just literally me making a direct call to Sean or a direct call to the PSTN or what have you. In this case, the media is going to flow as directly as possible between these two endpoints, right? So I'm going to try to go direct to Sean's endpoint. Now, we're both work from home, so I'm going to go out my internet circuit. He's going to go out his internet circuit. We're going to try to stun and go direct to each other, but if we can't, we'll route up through the service, we'll insert a TR, and we'll be able to talk to each other, right? But that's kind of that concept of a direct call. I want to be able to get there as quickly and as directly as possible. A meeting, on the other hand, right? This could be a meeting, something has more than two users or something that you schedule. This goes through the service always. Always, always, always. All meetings are always hosted in the service, right? Meetings are anchored on a media processor, right? The media processor is, the component that serves up the meeting itself. We want those media flows to go directly from endpoints to that conferencing service or to that media processor directly. That's what we would most prefer, right? The endpoints will connect directly via random high ports. That's the way it used to be. We've actually updated the media processors very recently to use the standard UDP 34, 78, 79, 80, 81 ports, right? The reason we put that particular bullet point in there was before we made that change, folks would do some testing from like their home office where, I don't restrict things going out my firewall. And I would go to connect to a meeting and I would see the IP address of the media processor and I'd go, hey, yeah, that's in the range that we talked about, right? It's 52.112.blah. Awesome. What? It's connecting on port 51,283. What? Well, yeah, because I didn't restrict it. And that's one of the offers that came back in the SDP. So I made the connection because it wasn't restricted. That's why that bullet's there. You may not see that. Ideally, you shouldn't see that much anymore because we've updated the media processors to use the standard 34, 78, 79, 80, 81 ports that we talked about earlier. And that's that last bullet. So even in that last bullet, we may insert a transport relay or we may connect you directly to the MP if you, haven't blocked that particular, port range, which is good. We also, from a media perspective, made a ton of improvements in the media stack itself. As Sean knows, I can spend a little bit of time on this slide, but I won't. These are a ton of video and sharing improvements that we've made. We've updated the mechanisms that we use for self-tuning, balance, and recovery, right? So long LTR is long-term, reference frames. IDR, instantaneous decoder refresh. FEC is forward error correction. RTX is retransmission, right? So there's lots of mechanisms that we've built into the algorithms that we use, not just simple, Oh, packet loss, turn on FEC, mechanisms like we used to do back in the Skype days. We have a resource manager that we use now, so that when we do a desktop share, we don't have to wait 15 seconds for it to kind of get fuzzy and then snap into a crisp view, because our bandwidth estimator, our resource manager, automatically figures out how to get the proper resolution when we do a desktop share. Many of you saw, well, I used it earlier, the idea of share system audio, right? The share system audio option allows the video to stay in sync with audio, but it also optimizes the codec for the scenario to focus on smooth and low latency versus the crispness of the image. So when you turn on share system audio, you might notice that the video isn't as crisp as it might be, but the audio should be buttery smooth. That's the way that we've adapted the codec for that share system audio scenario. That's why it's important to tick that little box, or as I did earlier, hit the little, allow system audio, option. Better low bandwidth support, right? Sustainability for usability. Try to get the screen sharing to have not less than half a frame per second, because that, anything less than that is just completely useless to try and look at. And making sure that we have a stable and steady experience, right? We have bandwidth caps, right, that you saw earlier, that 50,000, kbps number that you can put in play. We're looking at maybe investing in context-based caps to be able to, adjust the context. Maybe they're on a low bandwidth scenario, and maybe we can adjust the caps accordingly from that perspective. And last but not least, visually, when you see these things, you have a direct one-to-one call that looks like this, right? Here's our friends Alice and Bob, right? In this instance, they're both violating social distancing orders and actually going into the office. I'm kidding. They're actually in a corporate network here. Alice and Bob both behind the corporate firewall, right? When Alice and Bob fire up their Teams client and try to make this connection, there is a signaling path that always goes through the service. That is HTTP REST, right? Back in the Skype days, we called that SIP, right? That was the protocol that we used. We don't use SIP in Teams. This is done over 443 HTTP. So these are REST API calls that we make for the signaling path. But the media path itself ideally will go direct, right? So that's what it looks like here, going from Alice to Bob. If we don't have that direct connectivity, so there's Alice and there's Bob, but maybe they actually happen to be on disparate networks. Maybe again, they're at their home offices, right? The signaling path still goes through the service, right? But in this instance, because Alice and Bob can't send their traffic direct to one another, that's when the service will go, no worries, I'm going to insert a transport relay into the mix. And I'm going to allow that relay traffic to go from Alice to the service, and then from the service back to Bob. Right? And last but not least, that's the idea of peer calling. Let's talk quickly about meetings, and then I'll turn it back over to Sean. Meeting locations. We provide optimized meetings to minimize latency and provide this better user experience. Well, what does that mean? Well, it means that the first person that joins the meeting, we're going to determine where they are geographically, and we're going to spin up the media resources, the media processors in that region, right? So first user joins the meeting, I'm here in Southern California, right? There's going to be a resource, most like an MP, that gets spun up in the Azure West, DC, for me to connect to, right? That's the closest point to me. And then other folks that join the meeting, they'll come into that resource. Now, a lot of folks looked at that and went, whoa, wait a second, what happens if, and they always give me the worst case scenario. What happens if a user, it's a meeting scheduled with 10 people in the US and one person in like New Zealand or something. And they go, the New Zealand person joins first. So now everybody's going to go over to yeah, they will. Is that a very likely scenario? Probably not. And even if it is, I'm going to have the quickest path into the Azure network, and I'm going to go as quickly as I can over our dark fiber to get to that data center that's over in most likely Australia, right? Is it going to be the ideal experience? No, but it should be a pretty decent experience. But again, we don't architect the environment for corner case scenarios, right? We architect the environment based on how we expect folks are going to leverage service. And that's why when we look at media flows, we're going to go to a meeting based in user region. That's also why it's important to make sure you optimize the networking paths, because if you don't, and again, I'm here in Southern California, and you somehow egress me out internet circuit in Europe for some strange reason, that's where my media processor is going to spin up, and that's not going to be pleasant, right? We're not going to talk about direct routing flows because we don't have time, but I'll talk more about direct routing when I get into the direct routing topics on Monday. So with that, Sean,